There are a number of programming models when considering IoT devices. The model is chosen based on the application requirements, example, real-time system, hardware specification, software development kit framework, and software libraries availability, time to market, and even development skills. The bare metal programming model is where the software developer builds firmware, usually from scratch or based on a template generated by the software development kit, and then flashes it to the microcontroller. The common technique here is also to adopt existing samples that are brought to the developer along with software development tools and frameworks provided by the manufacturer. While the developer must implement all algorithm communication, interfacing, storage, etc., on a low level, it is common to use libraries either provided by the manufacturer or by the third party. The use of libraries speeds up the development process significantly. Bare metal programming requires a good understanding of the IoT device's hardware configuration and the software development toolchain configuration. In most cases, source code is written in C or C++ language. The development chain includes developing source code, compiling and linking it, and then flashing into the device as a firmware. The bare metal programming model is considered the only one that enables developers to have absolute control over the hardware on a very low level. On the other hand, it allows the implementation of non-standard solutions and optimal code in terms of compactness and efficiency. On the other hand, it increases time to market delivery. Recent advances in development supporting tools such as AI-based code generations, wide availability of libraries, standardization of their presence in the repositories, and automated management, such as Platform.io Library Manager, significantly lowers this time. Opposite to bare metal programming, script programming doesn't involve compilation or firmware burning into the flash memory. The programming model uses interpreted languages such as Python or JavaScript. The device has installed a language interpreter in the form of firmware or software, usually delivered with an operating system, if any. The interpreter, working as a middleware, acts as a kind of a virtual machine and brings a hardware abstraction layer to the developers. The middleware brings an overhead of executions. Thus, the model is intended for not so constrained IoT devices, such as more powerful edge class devices and quite common for fog class IoT devices. The interpreter may limit the development in hardware control, and because it adds an additional layer of execution, it is not intended for real-time application algorithms. The development process for scripting programming includes script authoring, uploading, and execution. The software development kit is usually simplified when compared to the bare metal development, but it is also limited. It barely provides debugging capabilities, but rather uses tracing. This programming model is suitable where the standard solutions are implemented and where code execution efficiency is not critical. It is also usually less energy efficient than bare metal programming. Because of its ease and implementation, the lack of need to install a complex software development environments, and the high level of abstraction, it speeds up delivery time to the market. Several configuration IoT frameworks are available for various IoT devices. This development model focuses on reconfiguring the ready-to-use firmware delivered as it is, using some configuration interface, configuration files, or scripts. Some open-source firmware, such as Tasmota, ESP Home, and OpenBeacon, offer high flexibility and reconfigurability, making it the simplest and fastest way to develop IoT devices. In contrast, proprietary firmware doesn't offer this opportunity and is delivered as is with a predefined set of features. Software modifications are not allowed, and configuration is limited to the changing the state of the elements, from simply switching them on and off to setting up access and credentials. This programming, or rather a configuration model, is the least flexible. It is worth mentioning that IoT hardware used to be compatible with more than one firmware, and proprietary ones can be replaced with alternative open source firmware.